So let us move to the next topic: exceptions, interrupts, and the vector table. You don't have to study much. You will have a big table of vector table over here, which is quite and pretty easy. Exceptions and interrupts, they are both together, like no difference. Like they have a difference, but they both are like always come together. So introduction to exceptions and interrupts. So when an exception or interrupt occurs, the program counter is set to a specific memory address in the vector table. See, always remember whenever the exception interrupt occurs, so the basic flow of instruction is disrupted and then it follows the vector table itself. Okay, so the vector table is located at 0x 8 zeros in the memory, and you know it can also be placed at 0x 4 times that, so that is a higher memory. And the flexibility is used for operating systems like Linux and stuff and all. Types of exceptions and interrupts. So you can see here, uh, reset vector. It is like either it is an exception or an interrupt. So the abbreviation, like short form, is reset. Address all are zero. Same basic one. So it's just like whenever you're on the system, that boot thing and all. So it's just like that first instruction executed power on. It branches to initialization code. Then you have undefined instruction. It triggers when instruction cannot be decoded by the processor. Undefined, see, just starting 5 let. Oh, okay, so fine, starting 4 letters. So the only the ending part becomes 4, remaining everything is same. Then software interrupt, the only ending part becomes 8, it's become S. Oh, something's wrong with the mouse today, but no problems. SWI, see, when executing SWI instruction, when it is triggered, prefetch abort, so it's CCPABT. Okay, it's triggered when trying to fetch an instruction from an invalid memory address. For example, you're trying to access something but from the wrong file or folder or something like that. So it's sometimes happen in your laptops itself. Like if you're not in administrator mode, you won't be able to perform or access a few things, right? It's just like that. So then okay, let's move to the data about dapt dabtc, just d, then this already it becomes 10 10. Okay, so now only this number change. Now again this number keeps changing, so it is raised when attempting to access restricted or invalid memory for data operations. Here the administration mode example perfectly fits over here. Then you have reserved mode. It is reserved for future use, which is nothing but for 14 14, and then interrupt request 18 and 18. So interrupt request happens when hardware like if there is an exception or interrupt, so the external hardware is requesting for the processor attention to solve something. So here IRQs must be enabled in CPSR. Okay, same explanation here, but just you have to mention it has more priority and fast response. It must be enabled CPSR. It's just 1C. Yeah, that's it. Then handling the exception and interrupts. When an exception occurs, the normal instruction flow is suspended, like we saw in the pipeline, right? The other stages are aborted, but only the execution stage, the execution is being performed or carried out. Here, the processor jumps to the vector table. I told you, right? Whenever exception or what is that interrupt is occurred, the normal flow is disturbed or suspended, and then it checks the vector table for reference. Each entry contains a branch register we saw above, and then it pointing the respective exception handling routine. It's just like routine. So here you have difference between IRQ and FRQ. It's just priority response time. Priority IRQ low, FRQ high, response time slower, faster. Usage, it's only in general purpose interrupt, external interrupt. Here it is time critical operation like DMA controllers and stuff. So here is a summary, key takeaways. The next part we'll be talking about the last topic of this module. So here see the vector table provides a structured mechanism for handling exception. Though they have not mentioned about vector tables completely over here, but here like this way you can if they just particularly ask about vector table, you can talk about this. before I end, okay, what is this? I can't see this. So let me just go to the state and instruction set. Yeah, that was done. uh, all this was performed. In pipelining was also performed, and exception, interrupt, and vector table. So see here, this is the vector table. Okay, so what we saw over there is actually exception or interrupt. See all this vector table, you just have to remember these addresses and stuff, right? So easy. Here it's just all these four things, but we also had the description over there. So see, it's just quite small, and I have explained in detail, so it's should be very easy for you guys to remember all these things now. So you can just see this. The vector table provides a structure mechanism for handling exception and interrupts. It contains branch. See, it contains branch instructions. What it do, provides a structural mechanism for handling the exceptions and interrupt. Reset undefined. So all these are the seven. How much? 1, 2, 3, 4, 5, 6, 7. See, the location of the vector table can be changed in some processor. Example, high memory. See, FIQs are faster than IRQs and are meant for high priority tasks. So that's it, guys. We'll see in the next video. This is the last topic of the module, and let me know how you felt about the explanation.